Cost savings through reduced labor costs occur because prefabrication allows completion of multiple tasks in a controlled environment, reducing the time spent on site. Optimized material usage happens because bulk purchasing and pre-cutting materials can minimize waste and reduce costs. Faster project completion through prefabrication enables quicker installation, resulting in potential savings on overhead expenses. Firstly, let's explore the pros of prefabrication, which include improved quality control. Controlled factory settings ensure consistent and high-quality products. Secondly, reduced installation time means pre-assembled components can be easily installed on-site, significantly reducing installation time. Thirdly, increased safety occurs because fabrication in a controlled environment minimizes safety hazards associated with on-site work. Fourthly, enhanced flexibility means prefabrication allows for rapid customization and adaptation to changing project requirements. Fifthly, reduced disruption occurs because prefabrication minimizes the impact on occupied spaces during installation. Conversely, there are cons. Firstly, initial investment for setting up a prefabrication facility requires significant capital investment. Secondly, transportation costs for transporting prefabricated components can add to overall project costs, especially for large or heavy assemblies. Thirdly, limited customization in prefabrication may not accommodate certain site-specific requirements or design changes. Fourthly, potential delays occur because unexpected design changes or material shortages can disrupt the prefabrication process and delay project completion. Fifthly, a skill gap can occur because specialized labor may be required for prefabrication and installation. Additional consideration should be accounted for. The cost-effectiveness of prefabrication generally increases with the size and complexity of the project. Access to skilled prefabrication and installation personnel is crucial for successful implementation. Prefabrication should be carefully planned to align with the overall project timeline. The extent of prefabrication may vary depending on the specific requirements of each patient room or area. In the case of the specific project described, prefabricating the high current feed, or HCF, cables connected to the 1900 boxes with mounting brackets, mud rings, and receptacles offers several potential advantages. Consider the following points. Cost savings can be realized through reduced labor costs. Assembling these components in a controlled environment allows for faster and more efficient work, minimizing the time spent on site. Optimized material usage can be achieved through bulk purchasing and pre-cutting materials, reducing waste and lowering costs. Faster project completion is facilitated because pre-assembled components can be quickly installed on site, leading to potential savings on overhead expenses. Improved quality control is ensured because the controlled factory settings guarantee consistent and high-quality products. Reduced installation time is a benefit because pre-assembled components can be easily installed on-site, significantly reducing installation time. Increased safety occurs because fabrication in a controlled environment minimizes safety hazards associated with on-site work. Enhanced flexibility is achieved because prefabrication allows for rapid customization and adaptation to changing project requirements. Reduced disruption is facilitated as prefabrication minimizes the impact on occupied spaces during installation. The initial investment can be significant because setting up a prefabrication facility requires capital. Transportation costs need to be considered because transporting prefabricated components can add to overall project costs, especially for large or heavy assemblies. Limited customization is a factor because prefabrication may not accommodate certain site-specific requirements or design changes. Potential delays could happen because unexpected design changes or material shortages can disrupt the prefabrication process and delay project completion. A skill gap could be present because specialized labor may be required for prefabrication and installation. Project scale is a factor because the cost-effectiveness of prefabrication generally increases with the size and complexity of the project. Availability of skilled labor is crucial because access to skilled prefabrication and installation personnel is crucial for successful implementation. Project schedule considerations need to be made because prefabrication should be carefully planned to align with the overall project timeline. Variations in project requirements should be accounted for because the extent of prefabrication may vary depending on the specific requirements of each patient room or area. Evaluating the project requirements, consider the uniformity of the patient rooms and other areas where these prefabricated assemblies will be installed. If the specifications are consistent across these locations, prefabrication can lead to significant efficiencies. On the other hand, if there are substantial variations in requirements, the benefits of prefabrication may be diminished. Assess the availability of skilled labor for both prefabrication and installation. Ensure that there are enough trained personnel to handle the prefabrication process and to install the preassembled components on site. Consider the transportation logistics. Determine the best way to transport the prefabricated assemblies to the job site, taking into account factors such as distance, transportation costs, and potential damage during transit. Evaluate the potential for design changes or material shortages. Develop a contingency plan to address any unexpected issues that may arise during the prefabrication process. By carefully considering these factors, a determination can be made about whether or not prefabrication is the right approach for your specific project. To further optimize the prefabrication process, consider implementing the following strategies. Firstly, standardize the design. Standardizing the design of the high current feed cable assemblies can streamline the prefabrication process and reduce the potential for errors. Secondly, use modular components. Modular components can be easily assembled and disassembled, allowing for greater flexibility and customization. Thirdly, implement quality control measures. Implementing quality control measures throughout the prefabrication process can help to ensure that the final product meets the required specifications. Fourthly, train personnel. Providing adequate training to personnel involved in the prefabrication process can help to improve efficiency and reduce errors. Fifthly, use technology. Utilizing technology such as computer-aided design or CAD and building information modeling or BIM can help to improve the accuracy and efficiency of the prefabrication process. By implementing these strategies, you can maximize the benefits of prefabrication and minimize the potential drawbacks. In addition to the general considerations, it is essential to examine the specific electrical codes and standards that apply to the prefabrication of electrical component. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including those involving prefabricated assemblies. Firstly, ensure compliance with the National Electrical Code. All prefabricated electrical components must comply with the relevant requirements of the National Electrical Code. This includes but is not limited to proper wiring methods, grounding, and overcurrent protection. Secondly, obtain necessary approvals. Obtain all necessary approvals and permits from the local electrical inspector before installing any prefabricated electrical components. Thirdly, label prefabricated assemblies. Clearly label all prefabricated electrical assemblies with the appropriate information, such as the manufacturer's name, model number, and electrical ratings. Fourthly, provide documentation. Provide documentation to the electrical inspector demonstrating that the prefabricated electrical assemblies comply with the National Electrical Code and other applicable standards. Fifthly, conduct inspections. Conduct thorough inspections of all prefabricated electrical assemblies before installation to ensure that they are free from defects and comply with all requirements. By adhering to these guidelines, it can be ensured that the prefabricated electrical components are safe, reliable, and compliant with all applicable codes and standards. When considering the cost savings associated with prefabrication, it's important to conduct a thorough cost analysis that takes into account all relevant factors. This analysis should include direct costs such as materials and labor, as well as indirect costs such as overhead and transportation. To perform a thorough cost analysis, firstly, identify all cost components. Identify all of the cost components associated with prefabrication, including materials, labor, transportation, overhead, and equipment. Secondly, estimate direct costs. Estimate the direct costs associated with each cost component. This includes the cost of materials, the cost of labor, and the cost of equipment. Thirdly, estimate indirect costs. Estimate the indirect costs associated with each cost component. This includes the cost of overhead, the cost of transportation, and the cost of insurance. Fourthly, compare costs. Compare the cost of prefabrication with the costs of traditional on-site construction. This will help you to determine whether prefabrication is a cost-effective option for your project. Fifthly, consider the time value of money. Consider the time value of money when comparing the costs of prefabrication and on-site construction. Prefabrication can often lead to faster project completion, which can result in significant savings in terms of interest costs and other financial expenses. By conducting a thorough cost analysis, you can make an informed decision about whether or not prefabrication is the right approach for your project. Furthermore, consider the environmental impact of prefabrication. Prefabrication can often be more environmentally friendly than traditional on-site construction, as it can reduce waste, conserve resources, and minimize disruption to the surrounding environment. Consider reducing waste. Prefabrication can reduce waste by allowing for more precise material usage and by minimizing the amount of scrap generated on site. Consider conserving resources. Prefabrication can conserve resources by allowing for the use of recycled materials and by reducing the need for transportation of materials to the job site. Consider minimizing disruption. Prefabrication can minimize disruption to the surrounding environment by reducing the amount of noise, dust, and other pollutants generated on site. By considering the environmental impact of prefabrication, you can make a more sustainable choice for your project. In conclusion, prefabrication offers a range of potential benefits, including cost savings, improved quality control, and reduced environmental impact. However, it is important to carefully consider all of the relevant factors before deciding whether or not prefabrication is the right approach for your project. Be sure to evaluate the project requirements, assess the availability of skilled labor, consider the transportation logistics, evaluate the potential for design changes or material shortages, ensure compliance with electrical codes and standards, conduct a thorough cost analysis, and consider the environmental impact. By taking these steps, you can make an informed decision about whether or not prefabrication is the right choice for your specific needs. One final consideration is the importance of communication and collaboration between all parties involved in the prefabrication process. This includes the project owner, the architect, the engineer, the contractor, and the prefabrication vendor. Effective communication and collaboration can help to ensure that the prefabrication process runs smoothly and that all of the project requirements are met. To foster effective communication and collaboration, establish clear lines of communication. Establish clear lines of communication between all parties involved in the prefabrication process. This will help to ensure that everyone is on the same page and that any issues are addressed promptly. Hold regular meetings. Hold regular meetings with all parties involved in the prefabrication process. This will provide an opportunity to discuss progress, address any concerns, and make any necessary adjustments to the plan. Use Building Information Modeling, or BIM. Utilize Building Information Modeling, or BIM, to share information and collaborate on the design and construction of the prefabricated components. This can help to improve coordination and reduce the potential for errors. Establish a change management process. Establish a change management process to handle any changes that may arise during the prefabrication process. This will help to ensure that all changes are properly documented and approved before they are implemented. By fostering effective communication and collaboration, you can maximize the benefits of prefabrication and ensure that your project is a success. The specifics of the 1900 box, mud ring, and receptacle selection also play a crucial role. Choosing the correct components impacts not only the ease of prefabrication, but also the overall reliability and safety of the installation. Firstly, consider the box type. Select the appropriate 1900 box type based on the number of conductors, device requirements, and mounting method. Options include square boxes, handy boxes, and gangable boxes. Ensure the box is listed and labeled for its intended use. Secondly, consider the mud ring depth and type. Choose a mud ring that provides the correct spacing for the receptacle and allows for flush mounting with a finished wall surface. Options include adjustable mud rings and those with specific depths. Thirdly, consider the receptacle rating and type. Select a receptacle with the appropriate voltage, amperage rating, and configuration for the intended use. Options include standard duplex receptacles, ground fault circuit interrupter, or GFCI receptacles, and tamper-resistant receptacles, or TRRs. Fourthly, consider the cable type. Choose the appropriate high-current feed cable type based on the ampacity requirements, environmental conditions, and installation method. Options include non-metallic sheathed cable, or NM cable, armored cable, or AC cable, and electrical metallic tubing, or EMD, with individual conductors. Ensure the cable is properly sized and protected. Fifthly, consider the mounting bracket. Select a mounting bracket that is compatible with the 1900 box and provides secure attachment to the wall structure. Options include caddy clips, screw-on brackets, and adjustable brackets. Ensure the bracket is properly installed and supports the weight of the assembly. When prefabricating electrical assemblies, it is imperative to follow all safety precautions to prevent accidents and injuries. Here are some key safety measures to consider. Firstly, wear personal protective equipment, or PPE. Always wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and hearing protection when working with electrical components. Secondly, use insulated tools. Use insulated tools to prevent electric shock when working with live circuits. Thirdly, de-energize circuits. Always de-energize circuits before working on them. Verify that the circuit is de-energized using a voltage tester. Fourthly, follow lockout-tagout procedures. Follow lockout-tagout procedures to prevent accidental re-energization of circuits. Fifthly, inspect equipment. Inspect all equipment before use to ensure that it is in good working condition. Sixthly, avoid working in wet conditions. Avoid working in wet conditions as this increases the risk of electric shock. Seventhly, know emergency procedures. Know the emergency procedures for responding to electrical accidents. This includes knowing how to shut off power and how to administer first aid. By following these safety precautions, you can minimize the risk of accidents and injuries when prefabricating electrical assemblies. The choice of materials also affects the cost and durability of the prefabricated assemblies. Consider using high-quality materials that are durable and resistant to corrosion. This will help to ensure that the assemblies last for many years and require minimal maintenance. When selecting materials, firstly consider the environmental conditions. Choose materials that are suitable for the environmental conditions in which the assemblies will be installed. This includes considering factors such as temperature, humidity, and exposure to chemicals. Secondly, consider the durability requirements. Choose materials that are durable enough to withstand the expected wear and tear. This includes considering factors such as impact resistance, abrasion resistance, and corrosion resistance. Thirdly, consider the cost. Choose materials that are cost-effective without sacrificing quality or durability. Fourthly, consider the availability. Choose materials that are readily available from suppliers. Fifthly, consider the compatibility. Choose materials that are compatible with each other. This will help to prevent problems such as galvanic corrosion. By carefully considering the choice of materials, you can ensure that the prefabricated assemblies are durable, reliable, and cost-effective. Finally, document the prefabrication process thoroughly. This documentation should include detailed drawings, specifications, and quality control records. Proper documentation can help to ensure that the assemblies are installed correctly and that any future maintenance or repairs can be performed easily. When documenting the prefabrication process, firstly, create detailed drawings. Create detailed drawings of the prefabricated assemblies. These drawings should include all dimensions, material specifications, and wiring diagrams. Secondly, write specifications. Write detailed specifications for the prefabricated assemblies. These specifications should include all performance requirements, quality control standards, and testing procedures. Thirdly, maintain quality control records. Maintain detailed quality control records for all prefabricated assemblies. These records should include the results of all inspections and tests. Fourthly, store documents securely. Store all documents securely in a central location. This will help to ensure that the documents are readily available when needed. Fifthly, update documents as needed. Update the documents as needed to reflect any changes to the prefabrication process. By documenting the prefabrication process thoroughly, you can ensure that the assemblies are installed correctly and that any future maintenance or repairs can be performed easily. Consider the long-term implications of using prefabricated electrical assemblies. Prefabrication can offer numerous advantages, but it's important to assess how these assemblies will perform over their entire life cycle. Firstly, assess the ease of maintenance. Evaluate how easy it will be to maintain the prefabricated assemblies over their lifespan. Consider factors such as access to components, ease of replacement, and the availability of spare parts. Secondly, evaluate the potential for upgrades. Consider the potential for upgrading the prefabricated assemblies in the future. Will it be easy to add new features or functionality? Thirdly, assess the life cycle cost. Calculate the life cycle cost of the prefabricated assemblies. This includes the initial costs, maintenance costs, and replacement costs. Fourthly, consider the environmental impact. Evaluate the environmental impact of the prefabricated assemblies over their entire life cycle. This includes considering factors such as energy consumption, waste generation, and the use of hazardous materials. By considering the long-term implications of using prefabricated electrical assemblies, you can make a more informed decision about whether or not this approach is right for your project.